rolling.
All right. All right. Thanks for having me today. My name is Jeremy Druin, and I was going to talk a little bit today about password analysis and how we can use that information to help us when we're trying to crack passwords. And so my day job is penetration testing. I work for a large company in Kentucky, and also own Ellipsis Information Security, where I try to provide pen testing services for small businesses that can't normally hire some of the bigger companies to do that sort of thing. And teach a little bit for SANS, and also work on a project called Matilda Day 2. It's actually started by Adrian a number of years ago, and I try to keep that going. So today, wanted to first define what password patterns are and how to do the analysis on them, and then talk about some of the things I learned when I was looking into those, and then using those to try to do automated password cracking. So to start out with, I wrote some software to help out, and there's two modules. The project overall is bypass, and then there's the pastime module and the actual bypass module. And pastime does the analysis, and it figures out what the password masks are and their popularity. And as we'll see, the popularity is very important because whether you call it like the Pareto rule or 90-10 rule, 80-20 rule, what you'll find is that the applying the right mask is critical to getting the fastest results back. Bypass actually uses the information from pastime, and it tries to figure out what the password masks are and then automatically apply those to password cracking. So to start off with, when we talk about password patterns, we're talking about whether it's all letters or it starts with an uppercase followed by a few lowercase, then a number. Those are the patterns. And we use these symbols to represent the pattern. So LU for lower and uppercase respectively, D for digit, S is one of the symbols, and then A is any character at all. If you look in popular password cracking programs like John the Ripper and Hashcat, they have other symbols as well that are important. Things like W means a word out of a dictionary and things like that. But this is the basic idea. So in the example here, capital P pass 1 exclamation is ULLDS. So to measure the patterns, you use pastime, and it just has a few commands. It's fairly straightforward to run. And there's a couple examples down here at the bottom. The main thing is either you want to list the masks or you want to analyze the password. So the list masks feature is typically used by bypass. It wants to know what the masks are that it needs to use to try to crack. The analyze password is more for people who are trying to understand the passwords that they have in front of them. So these are passwords that have already been cracked, and you're analyzing them to try to understand what patterns did people use when they were choosing these passwords. So some of the test files I took was mainly from Ron Both's site, and then I got a couple of others as well, like RockU. And so I picked these ones here because they had a really wide distribution between the number of passwords. I think the Facebook Fish may had like 55 passwords, all the way up to the PHP BB had 100,000, 200,000 in it, so it was a pretty good set. All right, so to do the analysis, after you get the project off GitHub, basically what you end up doing is just run the commands like they were specified. So A is for analyze, and L is going to show us a list of the patterns. The -P is %. That one can be a little bit confusing, but it's a decimal representing the % of passwords that the masks represent. So in this example here for PHBB, I put in 25%. And so if I do the analysis on it, there's 184,000 passwords in the set. Sorry about that. All right, let's see. All right. All right. Any ideas, Adrian?
So is that coming to the right screen?
Yeah. Oh, okay. Just mirror it. Got it. All right. Sorry about that delay. Cool. Thanks, Bill. All right. I was going to say, just bill me. Awesome. All right. Thank you all. So I ran the analysis on the PHP BB in this case. And so first, let's compare what happens if you don't put in the percent. So I'll just basically just kind of let it rip and on all of them. So there's all the password masks. That's actually scrolls up a few screens that represent the passwords in this set. And they're just, there's tons and tons of them. I'm not even sure how many thousands there are. It's probably in the hundreds of thousands actually. But if we go back and we say, well, what if we only want to know the number of masks it takes to represent 25% of that password set, those 184,000 passwords? So what you'll find is it turns out there's only 3 masks needed to represent 185,000 passwords. And even if you increase it to 50%, there's probably somewhere around a dozen or something like that. So at 50%, it takes 11 masks. And you'll see this pattern happen over and over where you'll have these really high spikes starting out with the first mask representing tons and tons of the passwords, and then it very rapidly drops off. And ultimately, when you try to match up this slope, this pattern, it ends up looking a lot like an exponential distribution with the alpha being, you know, pretty intense to where you get a big drop off right away. And this pattern ends up holding true for all kinds of different sets. So it doesn't really matter which password set you pick, they all have this general tendency. So if I pick, instead of PHP BB, I'll pick, like, say, the singles.org list that was leaked out. And in this case, to get 50%, we only need 4 masks. And out of, that's 12,000 passwords that the 4 are representing half of all the passwords that are inside of there. So these patterns show up in both the marginal percentage and also the cumulative percentage. The marginal percentage just being how many passwords did any given mask represent. And then if you order those and add up the marginal percentages, you just keep a running total, and that's the cumulative percentage. So I checked about, I think it's about 15 or 20 different sets that were cracked, and also grabbed the RockU one. RockU is like a combination of a bunch of different passwords. It's actually kind of gotten bigger over time as people have added more passwords to the file. And it still held the pattern even though it wasn't really from one definitive source. And so what I ended up seeing is that if you need to crack just any password at all out of a set, and you're not really concerned about cracking 100% of them, or you're not picking on one particular individual in that set that, you know, say like the super admin and there's only one of those, then really just focusing on the most likely candidates, the most likely masks, is a good technique. You can get a bunch of passwords back really quick, maybe even like 1.5% of the entire set, and you can get them in under an hour really easily. Then the problem is, well, how do you kind of automate this? Because there's a bit of a chicken and the egg problem. Even if you learn this statistic about passwords, you still have to have passwords to analyze to crack the passwords, right? So if you're starting off with a hash file and you don't have any passwords cracked at all, you need some sort of techniques to be able to at least chip away at some of them in order to get enough passwords to run the statistics on, so that you can figure out what the pattern is, so that you can go back and apply the pattern. So I started running this again on lots of different sets, and the bigger the set, the more distinct this pattern was, where these first few patterns made the biggest difference. So the small set was Facebook Paste Bay. It only had like 55 passwords or something in it, and so the line's kind of choppy. But as you got bigger and bigger sets, you'll notice the lines start to get really clean, and that drop off is really distinct. So what I learned from this was you need a large sample of passwords to start with. That's very important. The more the merrier. And again, the context is important. So if your goal is to crack Fred's password or Bill's password, this may not help you much, because they're individuals, and who knows what they did, right? This is working on average. So if you just have a big set of hashes and you just need some passwords, then this technique worked pretty well. Also, we noticed that it follows an exponential distribution, so we can actually predict what patterns are going to emerge. If you start to see that some mask is becoming popular, you can predict that that mask is going to be in the top 5, top 3, whatever, because it's an exponential distribution. And recon on the target still was extremely important, because obviously some systems have some kind of password requirements, right? And so it doesn't really matter if the most popular mask in the entire world is 7 lowercase digits. If the system that you're working on requires an upper and a lower and a gang sign and a hieroglyph and everything else, right? So you really have to know about the target and understand what the possibilities are, so that you don't go, fishing in the wrong place. And the final thought is that the more passwords are cracked, the more I realized my techniques are biased, right? So, for example, let's say that I make a word list out of people's names, and I crack a bunch of passwords. Well, statistics are going to be biased towards passwords made from people's names. So they're going to be biased towards having all these letters kind of in like a chunk, right? And then maybe some numbers on the end or the beginning, or some symbols somewhere on the end or the beginning. But in general, a name is a sequence of letters, and so it produces a bias in the output. So using a whole lot of different techniques to try to initially get a foothold on the hashes kind of spreads that bias out a little bit. But you still always want to be aware that, especially like in my case, I'm the only one working on the project right now, and when you have one person working on something, you get maximum bias, right? So, all right, so putting these things to work. So what I wanted to do was create a program that could automate a lot of this work, but I had some restraints that I also wanted to put on it. So the context I'm using it in is you're in the middle of a pen test and you get some hashes and you just want some passwords right this second. Like that's the use case for the tool. If you want to crack all the password hashes in the file, it's probably not the right tool for you. And again, if you're going after a particular person, you're probably better off using phishing or something like that instead of, necessarily trying to crack like a really hard password. Certainly give it a shot, because if it works, that's a good day. But cracking a single hash sometimes can be frustrating, so if you're not lucky. I wanted it to run in a virtual machine. This was a requirement mainly for where I work. Virtual machines are used a lot, and so I wanted it to basically work on CPUs. And that's tough because that kind of eliminates Hashcat. And so now, for better or worse, you really end up needing to use John the Ripper if that's going to be a major requirement. Then also I wanted it to run in the default version of Kali and without any kind of modifications, because I was hoping to try to make it as easy as possible for people who are just starting out and just learning. As long as they understand, they're sacrificing performance for ease of use, right? I just wanted people to be able to get started quickly and start to understand what was happening fast, in hopes of teaching people more about password analysis. So with those goals in mind, I created Bypass, and it's essentially a wrapper around John the Ripper. It's a Python program. that interacts with John and gives it commands and work to do, looks at the results that are returned, and then that goes back and forth through several iterations until a certain number of passwords are cracked, and then it can do the analysis. Here's a couple of examples how to run it, but I'm going to go ahead and get it started over in the other window. Oh, sorry, let me make sure y'all can see this. So what I picked is, the LinkedIn hash set, and I think I got it off on both sites, but it's actually on a couple of sites. And then I divided it in half just to make the demo work better, because it's a really, really big hash set. So I just picked the first half for no particular reason other than to make it smaller. And I'll go ahead and get it started running. We can come back in a minute and check on it.
How does that handle salts?
So John actually handles salts for you as long as the salt is in the right format. So you can tell John, like, let's say like your format was a salt and a colon and a hash, as just making that up. By specifying the format, you tell John like what the format looks like, and then it knows how to tear it apart and then apply it from there. Yep, and you do have to specify the format. No free lunch on that, unfortunately. So you get the mighty error of death. No passwords loaded if you pick the wrong format. So nobody likes that. So the three basic techniques are base words, prayer mode, and stat crack. So stat crack was our goal, right? We were going to use the password analysis statistics to figure out what the masks were. And so stat crack is kind of self-explanatory. The base word mode is just letting you tell the system what you know about the target. So, for example, we're talking about LinkedIn here. So you might want to pick base words like link and linked and LinkedIn and in and li and things like that, right? And you would feed those words into the system because your intuition would tell you those are probably good base words to form passwords off of. The system will then take those base words and it'll run mangling rules on those phrases or words you give it. Tens of thousands of rules, I believe. It basically uses all the core logic rules, all the John rules, one rule to rule them all rules, all of them. And it just tries to use variations. Now, because it's using so many rules, you do have to kind of be careful about how many base words you give it. If you feed it 50 base words, it's going to be a while. Because you're talking about every one word you pass in, I think it creates something like a couple 100,000 guesses or something like that. It was a huge multiplicative factor. So it doesn't take much at all to get to 1 million, mangling variations. But I found this works really well. This is really good for a few passwords in every set. And in these gigantic sets like the LinkedIn set, just the 5 words that I mentioned was good for like 1,000 passwords right off the top. So that's where this is optional, and you pass it in with the -B option. The default mode, in other words, if you don't say anything at all, if you just say, here's the hash set, go for it, it's going to run the prayer mode, which is the core here is the Hail Mary. So it basically what it does is it takes a lot of really popular words, base words, words that people like to form passwords from, and it runs rules on those. I run as many rules as I can on the set without taking too much time, because again, remember the original goals. You want this thing to give you some passwords right now, very, very quickly. Certainly wouldn't want to run more than 30 minutes or an hour. That would be kind of like a really long time in this context. It does, and then it tries what's called the Hail Mary, which is just this gigantic list of already known passwords. So you're talking about things like the RockU dictionary, very popular, already known passwords list, and other popular lists where I got the passwords from and just threw them all into one file. It tries English and Spanish. I found Spanish is obviously very popular because it's second most popular language behind English. And I just picked the top 10,000 words out of those languages. obviously, I think Spanish has well in excess of 100,000 words, and English has something like 450,000, or it's an insane number of words. So that's too many. So what I did is I pared it down to the top 10,000. As it turns out, languages also follow the same exponential distribution that the passwords do. So if you pick the top 10,000, you're really getting like 90-something% of the usage of the language. Sports, team names, people's names, places, and cities and states and countries. You get the idea. So it goes through all these different iterations, throws these at it, and tries to see how many passwords can you get. If you happen to have a special format where you have the username and the password together, it actually runs the John single mode at the very end as well, so which is a good one in that special case. So finally, it has now a set of passwords, and it runs the statistical analysis that we did earlier, generates the mass. You tell it what percent you want it to use. 25% was the one we were using in the examples. And then it'll create the mass one by one, and then it'll let John work on those mass one at a time. So it's not actually mask mode though. So if you're already familiar with password cracking, there's a brute force technique that you can feed Hashcat and John the Ripper, and you can basically say, try everything that has, say, for example, 4 lowercase letters followed by a number. So that pattern, it would try every possible combination of the 4 letters, and then it would try adding the 1 number onto the end. So you end up with something like 26 to the 4th power times 10 numbers, right? And it's just gigantic amount of computation to do. What bypass does is it actually takes the popular base words that we talked about earlier, and it uses those to form the rules. So for example, in that we said 4 letters and a number was our rule we were going to brute force. What it would do instead is it would take all the 4-letter words that it knows about and then just add the numbers onto the end of it. So this isn't by any means going to find all the passwords, and it's not meant for complete lists. And again, it's all about speed. It's all about finding passwords as quickly as possible. So and that's what it means by a targeted whitelist. So again, the things I got out of it the most was learn about the target. Can't really overemphasize that at all. Knowing what passwords are even acceptable in the system, the hash format, the base words to use, using programs like Cool to screen scrape websites in order to get a good collection of base words was super important. It seems like you can never get away with anything in pen testing without doing recon. It's like, it seems like that's always the key component to all the pen tests, no matter what direction you're coming from. Use the base words for sure. Compile John the Ripper on Kali Linux, which actually violates one of the rules I had, that it had to be able to use the default version of Kali Linux, and it can. It has no problem with the built-in version of John. It's just going to run about half as fast as if you compile the latest, I think it might be 1.8 or whatever the latest one is out on the website. If you do take the time to compile natively, especially if you're running on real hardware and not in a virtual machine, then you'll get a vast performance increase. At least, I never had it not be at least twice as fast, even on a VM, if you compiled it locally. There's another program, Pipple, that does a great job with the password stats. So if you really want to see a lot of different stats from a lot of different angles on the passwords, then Pipple is a great tool to check out. Robin Wood wrote it, and it's on his site, which is DigiNinja. Can't remember if it's org or what, but it's DigiNinja site. And then finally, we said this one was wrapping around John the Ripper. So if you want to use Hashcat, which can offer better performance in some situations, then TrustedSec put out HateCrack, I think it was like 3 weeks ago or so, and it uses the same general concepts, and it has Hashcat under the hood. So awesome program there. All right, so while we were chatting, the program was grinding away on that LinkedIn set. And basically what it ended up doing is it started off using just some super popular words that I'm not sure if this guy's name is Hobo. I'm not sure how to pronounce it. Don't mean to be insulting there. But I read his blog and his website and looked at a lot of the work he had done, and it was pretty interesting. So I used his rules and his words to start off because they work pretty well. And then what the program does is it'll basically tell you how it's doing as it goes along. So it'll say like, well, that really really short list with those really short number of rules didn't really find anything, and it tells you, okay, there's 0. But as it goes down, it gets more and more aggressive, meaning it takes longer and longer to do the different techniques. And so as it gets down to about mode 4, which was the Hail Mary, it cracked 15,907 in just using that one technique. So that one, in this particular case, just happened to be a good hit. Of course, I should have used base words, like I said earlier, and that would have helped out too. So then it goes down to like rule 5, where it got another 5 passwords or so, and it ends up having about 20 different rules, and it'll tell you how it's doing as it goes along. So here it cracked 1 password using English words. Well, I should say 1 additional password. But when it got down to English words and it used the 1 rule to rule them all rules, which is not easy to say, it ended up cracking 3,733 additional passwords in addition to the 70,000 that we've already got up to this point. So you can see what it's doing is it's grinding through in these techniques one by one, trying to essentially just automate it for you, so that if it's your first shot at password cracking, this is going to kind of use what it knows about the best ways to get started, and it's going to run like the top 20 best ways to take a shot at a given password set. All right, so if you're interested in trying this out, it's on GitHub. And so if you scroll down a little bit, once you get over there, there's actually some setup documents that'll explain, assuming you're using a default version of Kali Linux again, how to use the git clone command to pull down the project, get it set up, and then there's a config file where you point it to the version of John that you want it to use. If you're using the default version, you can just use the default settings, but I had custom compiled on mine, so I had to point it over to the version that I had put in the opt directory. And it walks you through how to get it all set up, and then at the bottom it shows you how to run the commands, and then there's examples for each. There's at least 3 different examples of how to run each command. So any question up to this point? So where's the opportunities for improvement? Well, one of the things that I didn't realize at first is that how important the Spanish words were. And so I'm going back in now and I'm retrofitting a lot of it with more Spanish words and more Spanish words in more context. In other words, using those for the mass. Another thing that I found is that adding in more statistical patterns helps. There's some corner cases and some edge cases where there's some weird patterns that turn out to be kind of popular, and they don't come up very often. But again, each individual site is unique, so there are some hash sets that some more patterns would help. I need to practice with it more and just keep tuning it, and then getting better word list always helps. I'm always amazed at how when I find like a few more sports, or a few more people's names that doesn't even seem significant. You find like another 1,000 names somewhere on some list, and you throw them in there and add it to the 100,000 that are already there, and suddenly you're getting like 600 more passwords. It's real. It's real important to have really good solid word lists and to collect a lot of lists from a lot of different places and combine them together instead of just relying on the tried and true list. Nothing wrong with those. They're the most effective, of course, the ones that are very popular. But if you can go out and just pull down and add to your list, that makes a big difference. So improvements for ourselves. The biggest thing I think helps regular folks is two-factor or multi-factor authentication. So I know LinkedIn and Google and including Gmail, Apple, Facebook, Twitter, on and on, all offer free multi-factor or two-factor authentication in those cases. Also, Amazon has offered it for a long time on their AWS, if you had one of their AWS servers. But not terribly long ago, they actually started offering free two-factor for just regular Amazon shopping accounts, just what everybody uses to buy stuff. And they didn't even really make a big deal out of it, which I thought was a little odd because I was so happy when they did that. I was like, yay, because I already had an Amazon or AWS account anyway, and that automatically just started protecting my my regular shopping account. So that was good. The other thing is using the appropriate factor for the context. So I work with a lot of application groups, application teams. Although I do a lot of network pen tests, I still do a lot of web stuff as well. And I see a consistent pattern where, because people are very good at using passwords, right, remembering things and knowing what they're supposed to type in. Computers are lousy at that kind of stuff, right? They can't remember anything. They have to write everything down on hard drives or storage, and they're just terrible at remembering stuff. And so I'm always amazed when applications try to make their machines use passwords to log into other machines. There's no human in the mix. And so one of the things I would encourage is, if you're working with application teams, is try to teach them about other factors they can use. Like maybe the applications can use certificates to talk to one another, or the web services can use mutual authentication with each other, or some other technique where the machine-to-machine communication can be more about something you have as opposed to something and so I think that's probably the two biggest improvements I've seen just from being more aware about this sort of thing. So as far as people and Pipl, I think it's P-I-P-A-L, Pipl. This is the link to his project, and then also Trusted Sex Hatecrack that I mentioned has Hashcat, a link to theirs as well. But a quick Google on either one of them will get you right to them. They're both indexed very high on the PageRank. So, all right. So now I'd like to just open it up to any questions at all on password cracking, or how bypass works, or how to... I'm sorry? Yeah, absolutely. Yeah, MD5 for the win. Yeah, actually, that's a good question. So, I mean, the implied question is what kind of hash should I use for my site? How should I be a better developer? Yeah, I think Blowfish, Bcrypt, either one is good. So now Blowfish, I think, is the symmetric algorithm, and Bcrypt is I always get it mixed up. Bcrypt is the hashing algorithm. So for password storage, we would use hashes. We would not use encryption, not reversible encryption. So yeah, I always get mixed up too. So yes, but that's an excellent point, because with Bcrypt, it requires a lot of rounds to generate the hash. It's a lot of work. It's a ton of work for the computer to generate the hash. But let's say, pretend you're a website for a second. So the user comes along and they type in their username and their password, and you're the website. So you have to take the password that they offered, and you have to hash it, and then you have to compare it to the hash you have on file. And if the two match, the presumption is the person must have known the password. So even if a website takes, say, 2 seconds to make that decision, because the hashing algorithm is so onerous, that's okay. It's an acceptable user interface, decision. But if you're a password cracker and you're trying to crack the passwords, and you've got, say, 5 million words in your dictionary that you're going to throw up against these hashes, and it's taken 2 seconds every one of them, right? It makes the password cracking infeasible. At least brute force, or even guessing, really, right? Because it just takes too long. So a good hash choice is really important and can make all the difference in the world. Unfortunately, a lot of those better algorithms, you won't really find them in the standard libraries of the languages. So if you go to, I think, I don't know, ASP.NET, I don't think Bcrypt is in the crypto provider in there, right? And so you're kind of asking developers to, drive out of their lane just a little bit and go import a third-party library. and that can take some convincing to do. So that's kind of the downside of the really good hashes. All right, other questions? Yes.
You looked at the prints rule sets?
No, there's a Prince and a Markov in there too, and there's incremental, of course. I have not looked at either one of those, but what I did do is when the program gets done and it goes through all the different techniques, like right now it's on technique 11, 87,000 passwords. Wow, it's having a really good day. It's a lot of passwords. What it does is at the very end, it'll spit out a message and say, I did the best I could with what I had. Here's how many passwords I cracked, right? And then it'll go ahead and it'll tell you what the command is to switch to incremental mode. So all you have to do is copy and paste that line and just paste it in, and it'll go ahead and switch to incremental mode. Now, of course, the reason I don't have the tool automatically go to incremental mode is that's brute force, and it won't stop until it's done. And obviously, the program will run for however many years it takes, right? So that's why I didn't just automatically switch it over. But that's a good idea. I could look at those other modes and see if they have a fit somewhere in here as well. Those modes he's speaking of, they are modes that do some other kinds of statistical analysis, and they use that information, and it's built into John the Ripper automatically, so you don't need any other wrapper around it to do that kind of analysis.
Had really good luck with prints.
With prints? Yeah, the incremental is pretty good too if you got a big hash set, and especially if it's a fast hash set like a MD5s or SHAs or whatever. Yeah, so that's a good idea to do that. Now the prints mode, do you know how long it takes to run, relatively speaking?
I don't have anything.
Yeah, I don't either. That's why I was asking. So I was just curious if it would fit the original goals of the project or if I would blow out my timeline. Cool. Yep. And there's also some interesting rules there's one that HateCrack does that's interesting, where it takes word lists and it combines it with password masks and puts the two together. And as it turns out, that's one thing the two programs have in common, is they both do that, where they'll take like a word from a dictionary and then a pattern and run through all the patterns on that word. And that works out really well if, again, like if your base word is like, for example, a person's name, those kinds of rules work really well. If you have folks that are, say, like all their passwords are named after their cat, and you use cool on their Facebook page or something, right? And so you got their cat in there, then those kind of rules work out really well. No. All right, other questions? All right, cool. Well, thanks. Appreciate you having me today.